Ideally, when you run auto tiering, you want to place all the important stuff on the fastest drives, and everyone will be happy and want to take you out for dinner. Sometimes, if you're not careful, you can cause too many IOPS on the same tier. This can happen when there is either insufficient disk space for a single type of disk, or when the policies are not configured to take advantage of either the higher tier SSD or the lower tier nearline. In this case study, we're actually going to look at a case where there was a suboptimal configuration, and we're going to look at how making some changes, certain changes, can improve performance. In the next screen, I'm going to show you some HP 3-part balance charts, and these charts are designed to show the distribution of the workload across the various components. We're actually interested in knowing how well the performance is distributed across the back-end disk drives. Ideally, if the AO policies are configured correctly, then both the front-end response time will be excellent and the workload on the back-end tiers will be optimal. In order to determine if the back-end workload is well balanced, we will examine a balance chart that shows the read IO workload across the back-end drives, and we call this a balance chart. This balance chart shows two different bars. One for the DSS named Monetis _2849 _0, and one named Monetis _2849 _5. The green dot represents the average. The area inside the green rectangle represents the 10th and 90th percentile range, and the yellow rectangle represents the minimum and maximum values for the systems. By itself, these are not very interesting, but when you drill down to the individual disk drives, you can easily see the workload distribution on the drives. In the next chart, we're going to examine the workload distribution on the individual back-end drives. As you're looking at this chart, keep in mind that the workload is distributed across three different drive tiers. In this chart, the 450 gig drives have the highest average read IO rate. Ideally, the SSD drive tier would have the highest number of IOs per drive by a significant margin. And the second cluster of drives should be the fiber channel drives, which would account for the second largest grouping of drives and the second highest number of IOPS per drive. Lastly, we would expect to see the cluster of SATA drives accounting for the highest number of drives and the lowest number of IOs per drive. In this case, we see that something is clearly off because the fiber channel drives have the highest number of read IOs. In just a couple of screens, we were able to visually demonstrate that the AO policies are not distributing the workload in an optimal manner. And then in this next slide, we're going to take a look at what happens when we tweak the AO policy to limit the fiber channel capacity used by the lower priority AO policy and also add some adaptive flash cache. Notice that the chart for this day has the profile that we want to see, with SSDs being the busiest and fiber channel drives being the second busiest, followed by the nearline. With this compare chart, we can see that the profiles between the 2 days moved dramatically. And with this level of optimization, you can safely use the storage capacity you have without worrying much about impacts to performance. Let's summarize this adaptive optimization case study. The SSD drives were not being driven very hard, but the 10K 450 gig drives were being hammered. So we made a couple of changes. We configured the AO policies to limit the capacity on the 450 gig drive CPGs, and we also set aside some of that unused SSD capacity for adaptive flash cache, which operates outside of the AO policy. The busiest drives changed from the 450s to the SSDs, and IntelliMagic Vision made it real easy to see those changes.